Hello and welcome back to the final part 3 of the ASHTAS operative training video. We continue with module 4, installation requirements. Barrier system posts. A number of different post profiles are available and the correct posts must be installed for the system used. Whether they be a H or an I post, a Z post, box post, C post, sigma post, etc. But there is also weak post systems and strong post systems. I'll discuss these on the next slide. Posts can be contained in the ground. These may be driven, post-socketed, including trench foundations, and surface mounted. Some systems also require a blockout, a secondary profile that reduces the likelihood of vehicle tyres snagging on posts. Strong post systems. Strong post systems are designed that the post rotates or bends below the ground surface. Strong post systems provide structural strength to the rail. Strong post systems may require blockouts to prevent vehicle tyres snagging on posts. Weak posts. A weak post system are designed that the post bends at ground level with the foundation remaining intact. Weak post system is reliant on the foundation meeting minimum criteria for the resistance to permit the bending action. Looking at post holes, if a foundation for a post hole is to be successful, the sides of the hole must be vertical, else the foundation can easily disengage from the surrounding material, as shown in the picture. And noting, a piling rig should be used to drive posts into a foundation. Barrier systems post is used for two functions. To hold the rail or rope in the correct position so it functions correctly during impact. If the system is too low, the vehicle will pass over the system during impact and possibly impacting the hazard. If the system is too high, it can deform the top of the vehicle cab, potentially leading to injury or death of the occupants. To achieve this, the system may have been designed to break away from the rail on impact. To remove vehicle energy as it hits each post, the system may have been designed so the post deforms at ground level when a force greater than the value is applied. Posts must not be ripped out of the ground, else they become projectiles, that they may become loose due to impact. Noting, it is the responsibility of all members of the installation crew to ensure the system will perform as designed and tested. Following the manufacturer's specification will ensure this is achieved. Rails. Lengths of metal, normally steel, galvanized or coated in a similar manner to protect and preserve the product. Must be assembled in the correct manner on post at the correct post spacing. This assembly will include the lap of the system and the correct use of fasteners. Rail should not be stored. Rail should be stored with a slight incline to prevent white rust. The lap of the rails should be in the direction of travel. In summary, the post itself serves two functions. To hold the rail or rope in the correct position so it functions correctly during impact. The second function is to remove vehicle energy as it hits each post. This is part of the manufacturer's design. In addition, posts may be surface mounted on a steel structure or concrete slab or biscuit that meets the manufacturer's specification regarding strength and depth. A strong post system is a structural post designed to rotate or bend below the ground surface. A weak post system is designed for the post to bend at ground level and is reliant on the foundation remaining intact. A piling rig should be used to drive posts into a foundation. Post may be contained in a foundation. It's socketed, a galvanised steel box cast into concrete. This has an advantage for maintenance as a damaged post can be removed without damage to the ground and replaced, often without any mechanical aid. Moving on to wire rope. Wire rope must be laid correctly. This includes the direction of the lay, which way the wire rope is twisted. If the wire rope system is designed with a wire rope weave, this must also be installed as specified. Must be correctly tensioned. This will also be temperature dependent. Must not exceed the specified length per run. Both rails and wire rope must be installed as specified by the manufacturer. Around the world, different types of wire rope are used. However, in Australia, the 3x7 is the common wire rope used. Although, as installers, it is important for you to check to ensure you are using the correct wire rope for the product you are installing. If you don't use the wire rope specified, the installed system will be non-compliant, and also the system failure may result if the barrier is hit by an errant vehicle. The following video demonstrates the value of centerline flexible barrier, a before and after example. In summary, both rails and wire rope must be installed as specified by the manufacturer. The required measures that should be taken to ensure a wire rope system will perform correctly are: it is tensioned correctly, the weave is in the right direction, each run does not exceed the system's owner's specification. The following is the final part to the video, how barriers work.
So besides the barrier itself, at both ends, you often find a protective terminal like this one that saves drivers if they run into it. In the 60s, the state-of-the-art was fishtail or spoon designs that tried to distribute the impact across more of the vehicle. These were widely used decades ago and were awful. Unfortunately, this acts as a spear when struck head-on and can result in catastrophic injuries. In the late 60s, turn-on ends were used, which bent the rail 45 degrees and buried it in the ground. These prevented spearing, but vehicles could easily vault or roll over, which caused serious injuries or fatalities. In the early 70s, various breakaway cable terminals, like this one here, were invented to minimize spearing. It works by having the end roll away, with posts breaking off to redirect vehicles into a clear zone. These were used for 20 years, but phased out as they were too stiff for small vehicles and could still spear occupants. In this test footage, the guardrail smashes into the side of the vehicle and would dice up any occupants inside. Nowadays, we have energy-absorbing terminals that let people walk away from highway speed crashes. For example, this is the MSKT, MASH Sequential Kinking Terminal System, and costs around $3,000 US. All terminals, including this one, have to do two things: protect occupants that hit it head-on and anchor the guardrail. The MSKT, when hit head-on, dissipates kinetic energy by crushing and kinking the rail while shooting it out the side. Its post and anchor are designed to break away safely as the head travels down the guardrail and slows and controls the vehicle. What I found impressive is the terminal has to do the exact opposite and provide tension when the rail is hit. The cable and ground strut keep the post and rail from being pulled down, which is called anchoring. Otherwise, the guardrail releases from the end post and the vehicle runs into the hazard. Also, if hit where the rail isn't strong enough to redirect vehicles, the MSKT safely lets vehicles through, which is known as gating. That's not a problem, as engineers add a clear zone behind it. While there are other terminals, I'm going to talk about one more because it's cool. This is the Trinity Soft Stop. When struck head-on, it crushes the guardrail vertically, pulls it through the impact head, and shoots it under the vehicle. You can see how the guardrail slides through the impact head as seen in this assembly video, and what the rail looks like after it's been crushed. Not only does this keep the guardrail off the road, improving safety, but it keeps the rail anchored and maintains tension in the system. While the terminals for guardrails were fairly compact, I discovered these larger units are different. They're called crash cushions and are placed in front of fixed structures such as bridges, toll booths, and concrete barriers. Before crash cushions were created in the 80s, engineers used ramped ends, which produced dramatic and dangerous results. Nowadays, we use crash cushions in these three categories to safely stop vehicles. Starting with sacrificial systems like sand barrels, these slow vehicles down through the transfer of momentum. They're arranged by weight, from lightest to heaviest, so small vehicles can be gently slowed down and still protect heavier ones. These systems are cheap, around $3,000 for the parts, but anything hit needs to be replaced, and it's messy to clean up. These are also useful for construction sites, with one model using a metal sled that controls the vehicle as it crashes through the water-filled cartridges. There's also a mobile version that is mounted to the back of trucks that are used to protect road crews. Next, we have cushions like this Quad Guard M10 that are better for frequently hit locations. When hit, the steel structure collapses, but is designed to survive, and can often be reused by pulling it out with a truck. Afterwards, you have to replace the cartridges inside, which can cost around $900 each. Larger systems can use 6 of these, which can get expensive if hit often. For spots with many collisions, engineers use cushions that bounce back or can easily be reset when hit and requires less time and money to repair. There are many designs, but I found SCI's Smart Cushion particularly interesting. What's neat is the gas cylinder inside adjusts the stopping force based on weight and speed so cars and trucks have the right resistance. After an impact, the Smart Cushion can be quickly reset by pulling it out and replacing a few bolts. Other systems, like Traffic's compressor, use high-density polyurethane to absorb and bounce back after an impact. While restorable cushions can be double or triple the price of units that use replaceable cartridges, the repair costs are much lower, and with enough crashes, restorable units save money in the long term. This is just one example of how engineers can maximize protection and justify how your money is spent.
Moving on now to end treatments. These are generally 2 types of end treatments to terminate a barrier system. These are an anchor and a terminal. Anchors are used to restrain the end of a barrier system and to transfer impact energy to surrounding ground. Where there are constraints due to installation length, for example wire rope installations, the anchors are overlapped so the trailing anchorage protects the approach anchorage. For approach protection, gating or non-gating terminals are to be installed. These systems are designed to collapse and absorb vehicle energy. By using gating and or non-gating terminals, potential airborne events are removed. So looking at both gating terminals and non-gating terminals, gating terminals are part of a barrier system, tested, connected to barrier system. Alignment will be subject to the manufacturer's specification and if there are any road authority amendments. When impacted, the system folds away, it gates, requires a clear area, a run-out area behind it. Then you have non-gating terminals. Crash cushions also fall into this class of terminal. The system collapses within itself rather than gates, requires a smaller clear area, and is often used in median installations. Terminals will be present on the approach end, the leading terminal of the system. A trailing terminal at the end may be present for single direction traffic. If there is the potential for an impact from either direction, either gating or non-gating terminals leading must be fitted to both ends. If installing, say, a length of W-beam barrier along a section of 2-lane, 2-way road, as shown on the slide, a leading or approach terminal should be installed at both the approach and departure ends of the installed barrier system. This is done because if an out-of-control vehicle crosses the centre line, an approach terminal will be available if required. So in summary, non-gating terminal. A road safety barrier terminal that is designed to redirect or contain an impacting vehicle and absorb part of the energy of the impacting vehicle at any point along the terminal without allowing it to pass through the device. Non-gating systems which include crash cushions, are more self-contained, and if a clear space is required, it will be far smaller. Gating terminals, a road safety barrier terminal designed to allow an impacting vehicle to pass through the device. As such, a gating terminal requires a clear space behind the installed system to allow the system to move on impact and for the vehicle to stop. Both gating and non-gating terminals slow an impacting vehicle to reduce risk of injury to the occupants. Moving on to crash cushions. Crash cushions act in a similar manner to non-gating terminals. They collapse on impact. However, they act in a manner similar to guardrail for side impacts. They are tested as a standalone item, not part of a barrier system. The rear of the system is a hard surface. They are designed to be impacted end on and generally on both sides and perform in the same manner. They are often tested for bidirectional traffic, so can be located in a median. They may be used to protect the solid end, i.e. concrete barriers. They are normally made from steel, but many temporary crash cushions are made from plastic and filled with water. And again, in summary, ramp terminals. Ramp terminals are not considered for any traffic flow where a vehicle can drive into it. As a result, the use of exposed ramp terminals on the approach end of road safety hardware is prohibited by ASHTAS. However, if a ramp terminal is used, the most suitable location to avoid an airborne accident is at the departure end of an installation if there is no two-way traffic flow. Crash cushion. On impact, a crash cushion is designed to collapse on impact as the sides of the crash cushion act as a piece of guardrail. Interfaces, transitions, and overlap. The transition is defined as a change within the road safety hardware installation. May also be defined as interfaces. The following are the AusRoads definitions. Transition, the connection of two road safety barriers of different design and or performance. Interface, the length of road safety barrier used to connect systems with different operating characteristics, commonly used to connect a non-rigid road safety barrier to a rigid barrier, such as a bridge safety barrier. Overlap, the interface between the two different stiffnesses of barrier system may be provided by overlapping the system. The systems are to be separated by the dynamic deflection of the terminating system. The overlap will protect the start of the second barrier system. In summary, a transition is defined as a change within the road safety hardware installation. These can include a change in material, containment, or shape/profile. When overlapping two different stiffnesses of barrier system, the systems must be separated by the dynamic deflection of the terminating system. If an operative is unsure of an installation activity they are working on, they should stop work and request clarification from the lead installer, supervisor, or site manager. When installing the rail, such as W-beam, the rails must overlap in the direction of traffic flow. If the system is too low, the system will not perform as the manufacturer's specification. The vehicle will pass over the system during impact and possibly impacting the hazard and potentially causing greater damage to the vehicle and occupants. Both rails and wire rope must be installed as specified by the manufacturer. Now we'll look at fasteners. Just as the correct posts, foundation and anchorage are required for ensuring the installation system will work as designed and tested, failure to use the correct fasteners and or tighten correctly may result in serious failure. It is responsibility of every person working on the barrier system to ensure that each connection is installed correctly. As installers, you are required to ensure that Only the correct items are used and tightened as specified. If washers are specified, washers are used for various reasons, including spreading of loads. If they are specified on both sides of the joint, then ensure they are fitted. They prevent loosening and can act as spacers. Nuts and locking threads. The system manual will detail the fasteners to be used, where and how they are installed. Nuts be tightened to the correct tension, torque, must always be installed on the correct face, must be of the correct grade, strength of material, may be used for various purposes. Standard nut, twin locking nut or lock nuts, an insert locking nut, a flange nut. The flange replaces the washer. The flange may have serrations to prevent loosening. Chemically bonded threads, only use a nut specified by the system owner. Screws and bolts. Screws and bolts are designed to do different tasks, so the correct item must be used. Screws are designed to work in tension, compression, holding together or stopping parting. Bolts are designed to work in shear, a crossways force. The shank, the unthreaded section of the bolt, has more surface area than the threaded section, so it is stronger. For example, in an M16 bolt, the thread has 150 square millimetres of material at point, whereas the shank has 201 square millimetres of material at point. The install system will not work correctly if the fastener is too weak or too strong. This slide demonstrates the tension joint and a shear joint. Summary: torque and validation records. The equipment applying the torque is to be validated with traceable calibration records, and the tool is to be used within its validation period. Validate 10 fastener sets after half an hour of continuous use. If okay, continue, else reset the load cell. Torque testers. When recording results of the calibration of the torque wrench, the lead installer or installer should sign this off. Summarising, screws and bolts are designed to do different tasks. Therefore, bolts and screws are not interchangeable. Nuts must be tightened to the correct tension, torque. Bolt and or screw head should be held with your spanner or wrench while the nut is rotated, not the opposite. They must always be installed to the correct face and be the correct grade, as specified. A bolt is normally 1.5 diameter thread at its tip, and the rest is shank, is left plain. An insert locking nut cannot be accurately tightened as the nylon ring provides a friction fit. This type of nut should only be fitted with hand tools, as impact wrenches may burst the nylon insert. The purpose of a twin locking nut is for the second nut to prevent the first nut from loosening. Continue on with the summaries. As you can see from the table, that the cross section area, the thread, is a lot less than the cross section area of the shank of a bolt. The install system will not work correctly if the fastener is too weak or too strong, if it has been over or under tension and or incorrectly assembled. Using the manufacturer's installation manual and system specification installation drawings will ensure that the installer/operative is using the correct bolt or screw for the system they are installing. Temporary systems. Temporary systems are tested in the same way as permanent systems, i.e. to MASH. Barrier systems used for temporary systems may be used as a permanent system. However, this is subject to approval by the relevant road authority. but not all barrier systems may be used as temporary systems. Temporary systems are normally freestanding or surface-mounted systems. These systems may be made from reinforced concrete, metal, steel, and/or plastic, dependent on the required protection, speed of traffic, speed of the vehicles, etc. Temporary systems offer protection not only for the road worker, but also for the road user. When works are finished, there should be no evidence of the temporary barrier system being deployed. In summary, depending on the required protection, temporary systems are normally freestanding or surface-mounted systems made from reinforced concrete, metal, steel, and/or plastic. Temporary systems are normally deployed as freestanding or surface-mounted road safety barriers, RSBs. And under no circumstances can a safety barrier operative move temporary traffic management measures. This would need to be undertaken by trained temporary traffic management installers delegated to that worksite. If an operative finds that the installed traffic management is obstructing the work, they should report to the lead installer, supervisor, or site manager. Installation requirements. Only road authority approved products can be installed. This will be location specific. Only trained personnel can undertake installation activities. This is the start of this journey. All installations must meet the system owner's requirements and may include location variation, road authority amendments with regard to assembly and build. All installations are to comply with the barrier system designer specification with regard to location, length, and performance. We need to provide a right first time activity in a safe manner with a quality handover. This is a responsibility for the operatives and installers. Inspection, maintenance and repairs. These activities must be undertaken by trained personnel. The manufacturer may specify a cyclic inspection and maintenance regime. Records of inspection, maintenance and repair must be clear and concise. When undertaking routine inspection, installation and design records are to be available so non-standard elements can be identified and checked to the design standard. Any damage must be recorded with a bill of materials for replacement parts. If the system is found to be unsafe, your manager must be notified at once. So in summary, inspection, maintenance and repair. These activities must be undertaken by trained personnel, as a minimum, the appropriate product training and be able to demonstrate practical experience. And finally, please remember, your work area is a hazardous environment. Be aware of your surroundings. Look out for your work colleagues. Ensure your traffic management is appropriate for your work situation. Noting, traffic management signs and devices shall only be moved/altered by authorised personnel. Ensure you follow your work safe method statements. Report all accidents, incidents and issues. Follow the manufacturer's specification to ensure a quality outcome is achieved for the barrier installation. Remember, be safe. You are to go home in the same condition as you came to work. This is the end of the ASHTAS operative video presentation. A time will be allocated to meet online with your trainer. This online session will include a short recap of this training video, discuss installation and design issues, information regarding the ASHTAS operative test, and complete the online ASHTAS operative test. The online operative test, it's a test that comprises 30 multiple choice questions. It's an open book test. The pass mark is 80%. Questions have 4 answers. Only one is correct. If you do not achieve the pass mark, you may reset the test after a period of 21 days. Thank you for your attendance and please stay safe. Remember, Think safety, act safely, and be safe.